Hello everyone, how are you? Okay, so I'm Monica. So before jumping into my profile, I just wanted to know how many of you are attending this event for the first time. Okay. One more thing, how many of you are professionals? Just raise your hands. If we have a good count. And Krish, I think you are a professional for me because he read a book when he was in fifth class. So yeah, he's super talented. Okay, and okay, let's jump into my profile. So I'm Monica Rajput. I'm a CNCF Gurgaon organizer. So I usually host event, and I have a big team with me: Ankit, Pankaj, and Satyam, Abhinav, lot of people. And also, so I work with four startup that is based on India, USA, and Singapore. So I have count of like 4 years of experience, and I also love mentoring students. And yeah, I'm organizer of CNCF Gurgaon. So how many of you know about the CNCF or CNCC Gurgaon? What is doing? What's the goal of CNCF? Anybody who can just tell me? Just please raise your hands. What we do? Anyone? No idea? Yeah, please.
Cloud native technologies like Kubernetes
Yeah.
and Docker, all the work that is going around
Yeah, that's
containers.
that's correct. Like microservices and
Yes,
all.
yes.
So CNCF helps to maintain those projects that is open source and that is related to the cloud native technologies. So yeah, so I just wanted to tell so far what we done in CNCF Gurgaon. So that is kind of our timeline. So yeah. So in September 27, 2023, we got an email from Andra. Audra, sorry, from Audra that okay, you can open an organization that is called CNCF Gurgaon. So in 27 we opened this organization. So I was not into cloud native technology at all. So I just fill out the form. Okay, let's see what is going to happen. So I just fill that form and okay, then we started planning. Okay, how we want to do the events and all. We build a team for like 4-5 members. Yeah, so September, October, November, काफी time लग गया हमें एक event organize कराने में. So that's a lot of time. And then in December 2, we got the venue and food from the ThoughtWorks company. If you heard about it. So there, it's a picture. Can you zoom it out? Just. Okay, so ThoughtWorks, we have, so you can see our smiley faces. Although we are not that much people in that event, but yeah, it was fun event. So we have Ashish. So we have Ashish. So he was our speaker that time. So we did a lot of activities like everything like food and all was amazing that time. And the talk were also good. Okay, on Feb 24, after December, January and February, it takes 3 months, I don't know why. But okay, on 24, we hosted an event with the event system. So we host the event with the EPAM. So you can see here, this time we have a lot of people, right? Yeah, and very exciting thing about this event. This time we have a lot of women. So that is a thing we consider a lot because we need a lot of women in the community. So that's important for us. So if you are coming for this event, so I really encourage you will come for the next one and the next one and the next one. Okay?
Sure.
So now, 3 months again, we are doing this event with the Deftron, with the Akanksha. So here is one more story with Akanksha. So me and Akanksha met in 2019. So we wanted to do a collaboration, we wanted to host an event. So yeah, we planned, but it was not executed because of the COVID-19. So finally, after 4-5 years, we are doing this event with collaboration with Deftron and Akanksha. So yeah, I think I have those photos when we
Yes,
were
I also
eating
have
pizza.
that.
So
Life
I
is
can't
like
show you because I can't show the image because that is terrible. Like I was terrible in that photo. Okay. Now, okay, we will click some photos and then I'll add the photo here. And the great news is this time, the next month, we are going to host an event on July 1st week. So, okay, I'll give you the announcement later with whom we are collaborating this time. It's a big organization. So, it's in Fang. So, yeah, we will do that. So, हमें अब कोई tension लेने की ज़रूरत नहीं है. We have now office and the food, all is done. So, okay, we will see on July. So, yeah, you will come.
Definitely.
Definitely. Yeah. Okay. Next. Right.
It's a pinky promise.
CNCF. So I don't know much about what is CNCF. We have a lot of amazing people out here like Ashish, Satyam and Krish. They know a lot about CNCF. So I can tell you in very simple and lame terms what is CNCF. So CNCF is an organization or you can see a foundation that have project like cloud native project जो होते हैं ना companies जिन projects को donate कर देती है, we can't handle those projects, yeah, and companies don't market some projects. So CNCF promote those projects and maintain those projects. So that is the simple and lame term what I understand. Okay, yeah, what I just told you, creating a vendor neutral environment. So anybody can contribute to the project. No one is owner, right, Satyam? Yeah, thank you. And driving adoption. So adoption means what I just tell you. They just donate their projects to the CNCF Foundation. So we can, maintain those projects and we can use those projects in free. In free, right?
Yeah, that
Depends on your requirement. If you want something.
there are multiple projects like proprietary sort of projects
Yeah.
also there and open source projects are also there. So you can use the open source projects.
I think we have 180 plus projects or 130.
160 projects as far as I know.
160 plus project we have. So you can choose any project you want to, contribute. So we have. So you can contribute. You can start contributing in README file also. So yeah, I started with that. So वो मेरा first and final था. Okay. So yeah, next slide. So in the next slide, we have a cloud native landscape. So what is cloud native landscape? In which you can get all the information about. Here you can see products related to the databases, products related to the scheduling and orchestration. If you are a data engineer, so you can kind of relate this thing. And if you want to contribute with service proxies, APIs, so you can just find out what's the thing you can contribute better. So that's a landscape. There's a lot of things here you can understand. Just go through it. So just do your work. This is homework for you guys. Okay, next slide. Okay, that is the thing. Maybe you hear about opportunities that CNCF Gurgaon, not CNCF Gurgaon, CNCF Foundation gives you. So my motivation to join CNCF community was when I scrolling, LinkedIn now. So I saw people are going Germany, America, in free, yeah.
Paris.
So you must be heard about the CubeDay, CubeTron, CubeCon, KCDs, yeah, CNCGs. CNCGs is this what we are organizing right now. And we have this DanCon scholarship. I hate this scholarship. So by this scholarship, you can go to America, Germany, or Paris, wherever. But काफी luck होना चाहिए उसके लिए. Lot of luck, because everyone is applying for this scholarship. So though I am not applying now, so you have a lot of chances. And we have some of certification and the trainings related to the Kubernetes and all the open sources. So you can just do that certification. It's highly recommended if you are doing a job. If you are a student, don't do that. I mean to say, with your money, please don't do the certificates. with office money or the job, you can do that. Yeah. And a mentorship, so you can get a mentorship from Satyam, Krish, Ashish, and from me or our speakers here. So you can get the mentorship, and we have a lot of people. It's a open source community, so you can message anybody from the community. Yeah, that is. Okay, that's all from me. Now let's jump into our speakers. Any questions so far? Or any inputs you want to give us? Anything? No? Before jumping into it, are you ready for the talks?
PPT भेज दो
It's going to be super technical. So sip of water if you want.
डेमो भी है ना
Okay, so our next speaker is Sudhanshu Prajapati, and his talk title is Running.
ठीक है।
How many of you are interested in LLMs? And how many of you are worked in a LLMs or on? So Sudhanshu has 2+ years of experience
इसको
in
कैमरे को स्ट्रेच कर दो
DevRel.
सुधांशु प्रजापति
So this talk is about how we can run LLM workloads on Kubernetes with Ray. So we'll deep dive how we can run LLM workloads, but first we have to know what these workloads are. You have, I think if you have been working in a space, and I think you have interacted with ChatGPT and or other kind of LLM model, you might have known some of other things or one or two things about what these kinds of workloads are and what it takes to basically create an LLM, right, that you can run on production. So, but my intention from this talk is to give you a basic understanding or maybe a glimpse of how you can start from your own laptop and create or maintain a model, or maybe you can start with LLM journey if you have any ideas around it. So about me, I'm a developer advocate at Data Cloud, and I travel with things around cloud, data, and AI. AI is like a new journey that I'm taking right now, but I have always been interested in AI since my college days. So that's where led me to this project. That we order. But if you have any questions around cloud, data, I can pretty much answer something which I have worked on. And
क्या?
apart from that,
कौन सी? ये वाली
basically
भाई ये
journey.
साइट वेबसाइट
If I talk about
मेरे को याद नहीं आ रहा मतलब अरे मैंने तो मेल से कर दी ना मैंने भाई से शेयर कर ली अपने जीमेल पे
So recently,
second
what
वाला
I did is
कौन है?
I purchased Raspberry Pi.
उससे share करो।
Hobby that I used to
यही
do. So
मेल पे
bought
शेयर
that,
कर मेल पे शेयर
bought
कर
hack
मेरी मेल
to run
मोनिका
on
के मेल पे शेयर
basically attach it and kind of create my own local server.
Bro, उसको
which
छेड़ नहीं
I
सकता ना,
running in my
वो
home,
बोलता है।
and I can access
मोनिका की
all
ID क्या है?
of my cameras
मेल
from here. I
हाँ
can
इसका
access
जीमेल यहाँ
my
से
own
ग्रुप नहीं
password
नहीं
manager
इसको उनका
running
WhatsApp ओपन
in my home
उनको शेयर तो
on
करो
my NVMe
मेल पे कर
SSD
मेल
that is
पे
attached
कोई
to that.
दिक्कत नहीं है भाई व्हाट्सएप
And
पे
I have a lot of other
Mail
things
मैंने हटा
on
दिया
that. So
टाइम
it's kind of like my
अरे
own
एक second
personal
में
cloud.
मिलता
I can create any
Web वाला
container
है
on it and get any service like
भाई
I'm
मेल
working on
कर
that.
उससे पूछ लो
Apart from that, I do travel. Right now, I don't want to travel in Noida or especially in Delhi NCR. But I do outside. Last I have been to Shimla. Shimla is a very great place because maybe I went in a off weekend time. That really I liked it. Otherwise, I don't think Shimla is great during the weekend. And bike rides. So we want to talk about bike rides. So because we don't want to say somebody how much what's your topic speed or something like that. So we start with the agenda. Like I said, we will start from LLM workload, what they are, and why would you want to run on Kubernetes? That's the first question, right? Why would you want to run on Kubernetes? The whole cluster you want to run, right? And what it is, and where does it fit, and what's its ecosystem, how you can get the benefit out of it, and then a small demo of it, of running stable diffusion model. That's the only demo I can get working because you need a lot of resources to run a pre-trained LLM on any cloud. For that, you might have to request for external resources. We'll talk about what are the challenges around it in order to run a very large model on cloud.
मुझे प्रेजेंटेशन सेट करनी नहीं आती उस पर कैसे उसको ड्रैग
So,
करके
first of
राइट
all,
ले
we'll
जाएगा
start with what
ठीक
are
है बस ड्रैग करा अभी
I
यहाँ पे
think
जाएगा ना
if you
उसको
have
स्क्रीन
seen
पे
any kind of
उसको हटाना कैसे
figures and
तो वो जा रहा
terminology that
है
it
पीछे जा रहा है
is,
क्यों
you
अभी
can
तो
relate
चलेगा
to
अभी तो
it.
चलेगा आज ही हो
So there are some of the steps which involve in a LLM development process. first of all is data preparation, retraining, and alignment and evaluation, and then lastly the deployment. Right. We'll talk about deployment as well, but let's figure out the deployment process. It involves a lot of integrated process that it uses a lot of libraries to actually work with it, and that's where these workloads come into place, and that's what we call LM workload. For example, retraining involves model selection, data sampling, and hyperparameter quantification, and all these processes have some kind of a back story behind it, that how much problem it involves to actually run these things, right? Now let's talk about once you complete all these 5 processes, right, or more like 4 processes, you get your LLM trained. Basically, you save that checkpoint on your local system, maybe on cloud, and you go to the deployment stage, right? So all these 4 steps is more related to the person who is working in the data engineering field, maybe in who is an ML engineer, right? But since you are talking about cloud, I am interested in deployment phase, maybe a little bit more about side of like deployment process, but more onto the side of how you can do it, deploy it on Kubernetes. So once you develop your model, you push it to a model registry. It could be Hugging Face, it could be on own private, right? Okay. So once you develop your model, you basically push it to a registry, right? And after that, basically you have your trained model there, and you do once you basically get the model, you deploy it, right? And after deployment, your trained model might require more things than what is required. That is continuous learning. For example, ChatGPT 3 is kind of now very much outdated in terms of whatever requirements. If you have ChatGPT 4 or ChatGPT O or any other LLM as such like Llama 3 or any other latest LLM model, you might want to use that. You won't use a model which is very outdated in terms of knowledge and model, right? That's where you need periodic trainer, continuous learning, all other different processes to keep it relevant to the current world, basically, right? And after that, there are a lot of other features comes into play. That is how you can schedule your like I said, there are a lot of problems in the deployment process. You might create stuff, but it won't work. So once after your training models, basically create your training model, there will be a lot of problems with it that you might want to address, right? And it will involve continuous learning, periodic trainer, and all how you can keep that model relevant to the current space, basically. And only not just training per se, but there are a lot of problems involved around resources, which I think a lot of companies are facing right now who are working in the LLM space. And the biggest problem of all in the LLM space is the inference server. If you talk to any company who is working in LLM space, and the main point they will talk about is the inference server. Basically, that's the server where you load your model and you query to it, right? It has a lot of problems. Why? Because it can't scale like that, the way you want or any basic server you want it, right? So there are a lot of problems. I'm not going to go into deep into that, what's the problem in the inference server, but that's just high level 20,000 feet overview of what the problems. And then how you can enable monitoring and performance review of your model that deployed. So now we know what are workloads, what are LLM workloads, and we have defined what are LLM workloads, and what's the deployment process, and what's the deployment process, and what problems that it involves. Let's talk about.
Sorry to stop you, sir. So you talk about some different servers. Why do we need to load the model on the servers?
So it's not like your HTTP server, right? As per se, you can load your model. You need a server which can manipulate that data that you have stored in the weights and biases, right? For that, you need a different server, and that's where the inference server comes in. And there are a lot of different servers in the market, like Triton. Triton is another server. VLLM is another inference server. There are a lot of inference server in the market. So it depends on what fits your need. and what throughput and output and what kind of output you want to get out of that. Basically, in terms of user experience, you want to get out of that inference server. Right.
What is the exact consequences of like loading the model exactly on the server?
So
What are we getting out of it?
So I would say that's more of a question for a ML engineer, right? How that inference server works, how the model gets loaded, how it's being checkpointed, and what are tensors and all. If I talk about all these things, I think you will be sleeping just in a 10 minutes. So I think we can focus on the side of the cloud, because right now you can get any model, right? You can get the inference server, you can get the model from online, you can get Llama 3 or any other model C, and you can run it. So the problem of inference server we can talk about later on, but maybe after the session we can
Fair
cover it.
enough, sure.
Okay, but yeah, let's carry on. Let's not carry the away with the feelings. So now the question is, why to run on Kubernetes? We can run a VM. Maybe you can rent a VM, GPU VM from Lambda Lab. Or there are a lot of other companies out there which are lending right now GPU VM for you to train your model, for you to run your models, right? But why would you want to run on a Kubernetes? So there are a lot of benefits. We already know. We know what Kubernetes is and why people would want to use Kubernetes. Because it has a better resource management, right? And to achieve a fault tolerance, you know, you have a rolling process in how your pods are basically rolled, right? So your service is always up. So that's where you really want to use Kubernetes, right? And first of all, you can deploy it in an HA node. So basically, whenever you upgrade or do anything as such, your one service is always up, and you keep your traffic coming onto your models, right? And first of all, you can't do a spot provisioning on a VMs. You want Kubernetes to do it for you, and it's only applicable in case of the Kubernetes. So it's a lot cheaper compared to any VM instances that you run, and you can roll it whenever you want to. Right, you want a GPU instance, you can roll it, right? And you don't want it to just destroy it, maybe remove it from the pool, right? And why would you want to run it on Kubernetes? The another question is, it makes your life simpler to manage all the life cycle of an LLM. We'll see in the last what life cycle is and how it's being running, how it will be taken care of on Kubernetes. So now we are on the main topic, what Ray is. So Ray, first of all, we'll start from where Ray actually started from. What the main motivation for that project actually came from. The motivation came from that, I think, how many people have worked with the distributed system? That's the first question I want to ask you, because I don't know how many people know what distributed systems are. Can you please raise your hand if you know, or you have worked with distributed system in the past, any systems, as per say, maybe it could be Redis or Kafka and any system. So I think, I don't know how many people actually know about it, so let's first explain what distributed systems are. So you have one machine running, more like a VM or instance or container, and after that, one point, you will want to basically distribute your workload across multiple features or multiple machines, right? You don't just want to run it on one compute, because you can scale up to a one level. After that, scaling on a vertical scaling, basically. You can increase the resources of a VM up to one point. After that point, you would want to use the multiple other instances of it to basically run a process or something. In that case, you would want to distribute one single program or your task into multiple clusters, into multiple workloads, right? That's where distributed systems comes in. And these are not easy to implement. You can look at Redis, you can look at Jupyter, you can look at Cassandra. They have a lot of theories, a lot of things implemented into to make it work. There is a quorum in place, there is a leader selection, leader, slave concept. Now we have renamed the terminology of it. We don't say slave and leader as such, but the concept is like that. You have a master and a leader slave. So that's where this Ray came into picture, and Ray is a solution where you can easily distribute any application. It might not be just LLM workload, it could be any any application or any task that you might want to run in a distributed manner. or require a lot of resources, or you want it to run faster than your normal sequential program. In that case, you would easily can use Ray, and it's a lot easier for you to convert existing program into a Ray implemented one. So yeah, and so all the problems that we talked about around the LLM workload, they require distributed. They are distributed. They want to be in distributed nature because there are not enough resources in the one VM. So in that case, you would want to distribute, and to distribute, you need a Ray, right? So now moving on to, there is a picture I added there, or screenshot of a Ray project. So it has more than 31,000 K stars on it, and it's been around the industry for more than 10 years. And if I talk about who uses it, yeah. So who use Ray? You might be hearing Ray for the first time, but Ray is not in the industry like for a while. It's not a new in the industry. There has been a company, and one of the first company I would name it the OpenAI. That's the first company I would name because they run their workloads on Ray cluster as well, basically using Ray. And even Uber, Instacart, Spotify, all other companies, they use Ray to basically distribute their tasks. It could be around ML workloads, and it could be anything around which they want to distribute. In that case, they go to Ray, they choose Ray. It's not that there are not alternative to Ray, but Ray just stands out in terms of how it handles things. We will see how it handles things. So, what's the benefit of Ray? It's parallel, like I said, parallel and distributed. If you're talking about distributed, that it means the process will run in parallel, and you will have a true parallel concept, as you can see. And first of all, it's Pythonic framework. So whatever you do in it, it's Python. All the libraries on the support and everything is Python. It's written in Python. So yeah, and I think there is C Python support as well, but we are not going to go into that direction. But it has a support. It's completely built on Python. So if you're comfortable with Python, you can basically write Python code and easily with Ray. And it supports flexible APIs, but that's for the technical people who will want to get into what it offers for the people who want to do more than what Ray provides. And there is a Ray AI runtime, which is the important point of this talk. And we'll see what Ray AI runtime is. So this is an overview of Ray, what Ray is, and what lies in their ecosystem, what's the low level, basically the main library, or you can say the core library that Ray provides. And on top of that, there is a Ray Air, that is a Ray AI runtime. So what this overview provides you, gives you information about, you can run Ray on any cluster. It could be Kubernetes, it could be Azure, GCP, VMs, or anything, or even a bare metal cluster, right? And from that point of, from Ray core, that's the main library that Ray provides. And out of that, they created a lot other libraries which you can use to basically execute your ML workloads. And on top of that, there is an integration ecosystem built around Ray libraries. So we'll see how these libraries work in action. Maybe we'll talk about one or two. But yeah. So one of the libraries, basically, this is the main core library of Ray. After that point, all other framework, all other libraries which Ray provides are built on. That's the main base of Ray. So it provides a lot of key methods, the Ray init and Ray remote and Ray code and Ray get. We'll see them in action. So we don't have that much of a time to explain all these, but let's see them in action how they work. And Ray core has some primitives like task, actors, objects, and driver and job, right? And now we see how these primitives actually looks into a Python program. And if you have a Python program and you want to convert it into a Ray implemented one, in that case, it's simple as like writing a decorator on top of your Python function, that is @ray.remote, right? And the terminology of Ray is every function is now known as Ray task, and every class you write in Python will be named as an actor, And if you want to save something in storage, basically you generally save pandas data sets and all. How these get stored in a normal Python, but in Ray it will be stored as a distributed immutable object, and they will be distributed across multiple nodes. So right now these things might not give you a lot of gist of how these things are working, but let's see a actual implementation of task in Python and how it is being implemented in Ray. So you have a basic square function which does a square, and you have a for loop, and you basically get the result of four a limit of four squares numbers, right? But how you would want to convert to a ray is you just decorate it with ray.remote, and after that point ray will be responsible for that for function to be running in ray cluster, basically in ray library, how ray actually operates on it. So ray will distribute that function across number of workload that you have defined in ray configuration, basically, right? And once these functions are distributed, you can basically get feature of it. So if you have worked with Python multi-processing or multi-programming and features and all, you might get the concept of features, right? So Ray creates the feature for all these objects, and you get the feature, and after that, once you get the feature based on features object IDs, you can get the result of it. That's how simple is that. So why I'm talking all about this is because to implement multi-processing or multi-threading, no, we're not going to talk about multi-threading. It's in Python, everything is sequential. So GIL log is there to keep you in link. So there is nothing as such like a multi-threading as such or multi-processing. You have to create a process. So we are talking about it because it's a lot harder to implement multi-processing in Python. You would have to use a lot of libraries to get it working, and you would have to figure out how to manage resources, do garbage collections and all and everything, right? In that case, Ray does it with simply with just decorating of basically function with Ray remote, and you get your thing distributed across multiple workloads if you have any. Now later on, you write classes in Python, right? And those classes can be converted into Ray actors, and it's simple as that. You write a normal Python class, and you just decorate it with Ray remote, and once you decorate it, you can call that basically initiate that class with remote counter.remote, basically, as you can see in the example, and to access any of the method is simply that call the method, then you do increment.remote, and that method will be executed within a Ray ecosystem wherever there is a Ray cluster running, and it will do the processing there, right? And then there is a Ray object, basically how this, how you basically save any output or things like that, how you want to load any data in your memory or something, and how later you want to maybe access it, how you can do it with Ray, with create object. Now let's focus on this one, maybe because we'll jump onto the demo later on. So let's see how this actually works in action. So there is a function called read array, and it loads a file from a location, and it just loaded and returned it basically. There is another function called add, which basically is doing is loading a numpy array and basically adding it and getting the output to you. And what is happening here is now I have defined the task here, basically task here, which is basically function in case of Python, but in Ray we call it task. So there is a one task, there is a second task. So first we are calling task to remote, basically initiating the task with a file 1 and a file 2, and we are assuming these files are on a two different nodes which are running, right? And these files are local to these nodes. So what Ray will do is Ray will basically access those files from that location and load it into that your task, and whenever you want to basically execute it, it will see and ask Ray cluster to see where it can schedule basically, depending on the resources. So now how these things are actually working, we can see, like this is just on top of you when you execute and how this actually work, but in the behind how this work is this like, it is like this. So you have Ray cluster, And ray cluster is basically you have ray runtime, like I said in the starting, and runtime will create head node and worker and multiple workers, right? So ray head node comprises of driver, workload, scheduler, object, and all the different components. But I'm not going to go into too much of detail because I can see it's a lot to digest in just one slide. So we'll keep my focus on head node, worker node, and worker node. So I think you understand the concept of workers, right? You know how worker works. They execute the task for you, right? And head is basically, head is our brain. So basically, your ray brain lies in head node. That's the simple terminology to understand how ray works. So whenever you ask for ray to execute anything, what it will do is it will go to the head node and say, hey, I want to execute that function, basically a task. Can you let me know which worker, basically the workers here, which one has the resources to actually execute? It will ask head node which are the workers which have the resources to make me run this one, and it will schedule that your task into any of those workers. And once that it schedules, it basically works like a basically same as Python program. It's nothing different as such. So that's just a overview of how when you schedule a task, when you schedule any task, any class, or any workload, it will go to head node and ask, hey, if there is any resources and which worker has what amount of resources, where I can schedule that workload, and based on that, it will schedule to worker nodes. Right? That's the basic terminology of how ray cluster actually works, or how ray node and worker works. And that's what we were talking about. The main topic of this talk is like how I can run my LLM workload with Ray. What all these libraries does Ray provide? So Ray comes with their own libraries. Basically, they build their libraries based on Ray framework itself, and it has Ray data, Ray train, Ray tune, Ray serve. So depending on what your task is, you can use any of the library, and you can harness the power of distributed computing in your Kubernetes cluster. It could be on laptop, it could be anywhere, wherever you want, right? And where does Ray fit in Kubernetes? I think we talked about once you have Kubernetes, you have better resource management, and that's where Ray also get these benefits. It does resource management, scalability, orchestration, and have a great ecosystem for you to basically begin with. And this is just one of the examples that I got from Ray docs, that how people are actually using Ray to create whole ML infrastructure basically. Like how you can use Ray to create the whole ML infrastructure, ML as a service for other companies, right? You can use Ray in the bottom, which has auto scaling as well, and you can create each namespaces running different Rays and have different processes running all together. Basically, you can orchestrate a complete pipeline of an ML or LLM onto Ray cluster. So now we comes to the slide where we talk about how we can deploy it on Kubernetes. As simple as that, they have the operator called Kubray, which does all of the handling of how to create a cluster, how to run any workload, and that's where Kubray comes in, manages the whole life cycle of a Ray cluster. That's the basic working of Ray cluster. I'm not going into that because that's too much for you. So now we talk about basically three main components. Out of that, today we will be using Ray service in a demo, right? And we will also use Ray cluster in this demo. Let's understand Ray, but first we target the Ray cluster. So once you get your Ray started, you create a cluster of your head node and worker node. That's what Ray cluster basically means. Right? You create a cluster with head node and worker node, right? That is what your Ray cluster basically means in Kubernetes and even in Ray ecosystem. And why you would want to use Ray cluster, and why would you not want to use Ray job, Ray service, or any other thing? It depends on your use case. So Kubray is the operator, so it has its own CRDs, and these are the three CRDs which basically Kubray operator provides. So in case of Ray, the Ray cluster is just your basic CID in case you want to just have a cluster and get your workload done, or you want to do prototyping of workload. In that case, your A cluster comes into and will create a cluster. You can run your workload. Once you're done, you can delete the array CIDs and your cluster will be deleted from Kubernetes. That simple as that. And array service is basically is used when you want to serve any model, right? So like I said, Ray provides a lot of libraries. In order to use those libraries, you would want to first have Ray cluster running. Once your Ray cluster is running, you can run your workloads like running a model, doing data training or anything as such. In that case, and now when we talk about how you want to deploy LLM, in that case you would want to create a first Ray cluster. Once your Ray cluster is created, you would want to serve your application basically. In that case, it's like a mixed package. So it will first deploy you a Ray cluster and as well as serve the model for you. That's this CID does it for you. And we'll see the YAML of it, how we design an application in it, and how we design our Ray cluster in it. So, and Ray job is basically you have a single job like training job or any other job as such like pre-processing job. You create your CID called Ray job. Within that, you define your what the workload you want to run, and basically it will create your Ray cluster for you and run the job for you. And once the job finishes, it will clean the cluster for you. So you will have a clean Kubernetes cluster. So before the talk, I created a Ray cluster. So let me give you overview of a Kubernetes cluster and what workloads are running on a Kubernetes cluster. So I'm running the Kubernetes cluster on GCP cloud. So I have a cluster name called Ray GPU cluster, which running in an ECS out with total memory of 32 GB. It also have a GPU node running within it, and let's see how much of the memory we have in the GPU node. Is around, I think, 12. No. We have around 16 GB of memory available for the GPU to use basically. So it using a 2-node pool, as you can see. And let's see what our workloads running in this Kubernetes clusters are. So I am running 3 workloads. One is the Ray operator that we were talking about, and it's more of a deployment. So this is the commands that I run to basically run a Ray operator. So first is you get your Ray operator Helm installed, and once this is done, you can basically run, or if you have already basically Ray service created CRDs for yourself, you can basically apply it into the cluster. So let me show you one of the CRDs, how they look and what we are running in this cluster. Can you folks see this CRD? One of the Ray service thing that I'm showing on the screen right now. So this is the thing that we were talking about when we talk about what are the components of Ray. So this is one of the components of Ray. This is the one of the CID, and in here we describe what Python script or how we want to run that application, and later we define how we want to what resources we want in the Ray clusters. Basically, what memories and limits and all, what kind of worker group you want, how many replicas and such things you want running in the Ray cluster. And once you define all this Ray service CID, you can just do kubectl basically apply of Ray service table.fusion.yaml. Right. Once it's applied, you will get all the workloads running in your Ray cluster. As for example, you would have a head node created, you would have worker node created, and also you will see your operator running in the cluster as well. So as you can see, we have one operator running, and that operator basically created a stable diffusion head node and also a worker group. So like I said, head is your main brain of your Ray, basically Ray framework. Like it decides where you want to run your resources, what resources to run and all. And worker is execute what workload you want to run basically.
right? So once all of this created, it also creates a SVC service, so which you can use, or you can open that port to the internet. Basically, you can open that service for internet, and people can actually access it and basically execute the request at it. Basically, throw the request at it and get the request done. So let me show you one of the requests. So how I am running it. So first of all, since the cluster is private, I would have to use kubectl port forwarding to basically get it accessible on my local. So once I am done the port forwarding, I can run my basically any Python application on that port. That is 8000 basically. And to run it, I'm gonna just use. So let me show you where I ported that one. So this is the basically example request that I'm throwing at the stable diffusion model that is running in my cluster, and it's throwing at a local 8000 which I'm port forwarding the service that are running in Kubernetes, and I'm asking it to create this kind of prompt. This is the prompt that I'm sending into the that service that I'm running in the Kubernetes server, right? And this is the application that I deployed in Kubernetes, which has API ingress, basically the one endpoint that I'm trying to throw a prompt and getting the response back, right? And this is the reserve deployment, the library that we were talking about, reserve. It uses reserve deployment decorator to define what resources you need. In here, I am using one GPU. Like, it's easy as that. You just have to define what resources you want your classes to basically use, and you can just load your model. So we are using a diffuser library. If you are on Hugging Face, you can see diffuser is a library which is used for image models. It allows you to load any model from any model registry like Hugging Face and do inference on it. So basically, the inference server that I'm using is basically from Hugging Face itself, but the service which is running it is actually Ray service CIDs, and it's running using the library called Racer. So now that you know that what application is running, the service is running, I can access it. So let's throw a request at it. So let me just execute this Python script. So it will send a request to this cluster and write that output to this file. I've already executed this file. Maybe right now this output looks like this. Once we get the output, it might look something different from what it is. It will try to overwrite on that, right? And also, let me port forward another service, which is Ray dashboard, where you can see what is actually happening in your cluster. So this is what Ray dashboard looks like, and if you see, I have deployed a stable diffusion application on it. Basically, my LLM model, or it's not LLM, it's more of an image model that is running, right? And I can see what resources it's been using, what's the output, what's the logs and all, and I can also see how much resources it is actually consuming. See, this is my worker node, right? And this is the GRAM of that worker node, and this is the memory, and you can see it is using around 4000 megabytes, basically 4 GB around it, something like that. So it loaded that model, and okay, the model respond back. Now if we go to that image, it created some different kind of image I said earlier. It will try to override on that, and it created that image. Basically this image we are getting it from the stable diffusion model. It's running a very basic stable diffusion model which released early on. So if you run the latest one, any of the different model which is released right now, you might get a better response. So it's easy as that, and you can see all of this is running in a Kubernetes cluster. I don't have to manage how these things are basically being orchestrated in a Kubernetes cluster. Like You don't have to define how your service will access GPUs and how these things will orchestrate for you. It's easier that you just have to run kube operator. That operator will create a CRDs, and these are one of the three CRD that we talked about. You can use any of those CRDs to basically host your application or fine tune, do other operation on top of Ray cluster basically.
So you actually forwarded your resources over your company's 8,000 nodes.
Yeah.
But you're receiving it from like 8 to 6
So 8265 is a dashboard. So we also deploys a dashboard for you where you can see what resources are running, basically the whole cluster overview of Ray cluster. So if you see how much resources that Ray cluster has is this much. 6 GPU, 1 GPU, how much memory it is using, how much object store memory it is using. So yeah, auto create for you. So Ray deploy it for you, you can access it whenever you create a Ray. So Ray runs a command called Ray init that initiate a Ray instance, and that instance will take care of running any application on Ray. So, and that's where you get all these stats. That Ray init will also create a dashboard for you, basically host a Nginx server where you can access your Ray dashboard. So jobs are what, when we talk about jobs are basically like your training job, right? So in training job, you don't want to serve your job. It's not a serving application, it's more of a training thing. In that case, you would basically create a Ray job CRD, and you can deploy that CRD into Kubernetes. It will create Ray cluster, and then it will run that workload that you define. So all of this is handled automatically for you. You just have to write your application, how you want this application to basically work with. And see, if you see this application, it's using fast API. Basically, I'm creating a basic HTTP server with fast API, right? And to serve that model on that endpoint, and to give the resources for that model to basically run on GPU, I just have to define that it uses number of GPUs. It needs GPU to run, basically, right?
How many workers right now?
It is using only one worker as of now.
Can we make so that it uses more than one?
Yeah. So if we look at the YAML, the Ray service YAML that I've defined, right? So this is the Ray cluster config. So I have defined which version of Ray I want to use. You can define any other version, and which host you want to host your dashboard. So this is the spec of Ray head node, right? And for worker, you have a configuration to set up replicas, right? Now you can create 3 replicas, 4 replicas, depending on how much replicas you want of it, right? And Ray will make sure that your load is being distributed across all these replicas.
So let's suppose I have given one request. So
Huh.
this model, the whole model will have
One
one worker or
worker. One worker. So if you talk about, there is a other concept, all different concept of loading your model into shards, right? In a different workload. That is possible with Ray as well. Okay, but that's more of a more advanced use case, because first you would have to run multiple workloads. You have to shard your model in a way that it runs across all these workloads. But it's a lot easier with Ray, because you can define how many workload or how you want to do sharding of the model as well.
I will have to decide.
Yes, you can decide how you want to do the sharding. And there is a concept of Ray autoscaler as well. So in case you can do 0 to, basically you can downscale to 0 level. You don't have to run all the time your model, right? When you need it, you can basically serve it. That's how you can also do it in a service-less manner, I think, right? That's the way. So in Ray autoscaler, you create a Ray service, and based on number of requests, basically number of resources that is required to run, it will spin up more Ray replicas, and your request will be routed to these replicas. As simple as that. So that's what Ray cluster is and Ray is all about. And Ray service is how you can deploy your models. But there are other services like Ray cluster CRD, which only does one job, that is to create a cluster for you. Once you create a cluster, it's easy as running a Jupyter notebook on that. Basically, this is the overview of Jupyter notebook. I'm not going to run this Jupyter notebook. Do we have time? So we don't have time. So once you get your Ray cluster running, so you can connect to Ray cluster using Ray library. For example, right now I have a one node running in Kubernetes, and it created a service endpoint for me, which I can use here and to connect to it. It's available at 1001. Basically, your Ray client is available at 1001, and if I run that, it will give me the resources that node has, right? And it will say it is connected to that one. And once you connect it, you can run any kind of workload. For example, Ray, you can run Ray task, Ray actors. You can basically run any Python application you have created, right? And it all will be executed via Ray on a Ray cluster. So, yeah, that's about it. Do we have time? I can go through another demo. If we don't, we can. So, okay, fine. Let me just sum up my slides in that case. So, like I said, I created Ray cluster. GK cluster first, basically Kubernetes cluster, and deployed a Ray operator. And that Ray operator can basically handle all the custom CRD that I'm deploying for Ray, like Ray serve, Ray cluster, Ray job. And you can also deploy Jupyter notebook. Basically, that's you have to decide. And once it's deployed, you can run any workload on the Jupyter notebook that you run how normally in a Jupyter notebook. And yeah, that's about it. So if you have any questions, you want to connect, you can connect me on using that QR code. And I will be posting a blog on my company website around the Ray. So we might not haven't been gone into too much of technical details of how Ray cluster works, but if you have any workload which you want to distribute across multiple machines, or for example you are just doing a hobbyist kind of a thing where you want to custom train your own model, right? In that case, you don't want to run a whole cluster for yourself, or you don't want to buy a GPU machine to basically do the fine training and all. In that case, you can just basically create a Ray cluster using Ray launcher and train it for 15 minutes or 20 minutes, and you will get your LLM model on your local, and you can use it whenever you want. As easy as that. So, yeah.
Give a
That's about
round
it.
of applause.
I think people are sleeping right now. So how many got sleeping during the session? I'm not sure. I saw one sleeping. Yeah. Faizan, Psych. I already said, if you know things about Kubernetes, it's easier to relate to it, but it's not to digest in the one session. So.
Thank you so much, Sudhanshu. Okay, are you enjoying the session or not?
Okay.
I think so. You are not enjoying the session, right? You are? ज़बरदस्ती बोलना पड़ रहा है कि हाँ ठीक है. You can say it because we really give preference to bad feedback, so we can improve our event. So you can tell me, yeah, okay. I want to know one thing, like why you guys are here. What's the main goal? I just wanted to know. So you can just raise your hand and tell. Otherwise, I'll just choose one of you. Just tell me one goal, why you are here. Anyone?
Yes.
Okay, yeah, you go first.
Yes. Because the parent goal of mine is to get into any company.
Please.
Get into any company for the role of DevOps primarily. So I had this opportunity in the second year of mine wherein I was interviewed at this company called MyWays AI for the role of DevOps. But college was unfortunately like not allowing the students to go move out of the college, and they were seeking for attendance basically. So those 75% criteria such set out, so that would not be possible at that point. So in third year में आके बाद when I came here in Delhi, so I got this opportunity to in fact my CNCF projects पे I've been the open source contributor as well. So like just to understand the DevOps like in more robust fashion.
Where are you from?
I'm from Nagpur, Maharashtra. Nagpur, Maharashtra. Yeah, I've come here for like summer vacation. लोग बोल रहे हैं कि moving to hotter place from the hot place itself. Like जो Nagpur apparently is the center of like India. तो that's the कह सकते हो hotspot of like summer. तो बहुत ज़्यादा गर्मी पड़ती है वहाँ पे भी. और मैं इधर दिल्ली आ गया हूँ. दिल्ली is gotten hit its record somewhere around 52. So people ask me why did you come, do you go to Delhi and all. I had this motive just to like spend a week right here.
Delhi
So-
has that vibe.
yeah.
Delhi has that vibe. Like,
Vibe.
Yeah,
Yeah,
vibe.
yeah.
Yeah.
I've spent my 2 years, 3 years in Delhi, back in Delhi, so I was familiar with the places.
अनिकेत,
I've not gone to
अनिकेत,
places,
उसको
so I'm
आशीष भाई को बुलाना
better
एक
in the
मिनट।
exploration mode.
आशीष
So
भाई
I'm
को बुलाना
exploring the Delhi.
Yeah,
Going
that's
across
Great.
places.
So yeah, you can get a lot of opportunities. We
Yeah.
have the people who has 15 years of experience, Mohinder and Rohit. So you can connect with them
Sure.
and yeah, you know what you
Yeah.
need to do next. Yeah.
Right. No, I want to thank my friend of mine who is friend from Twitter.
Yeah.
So I suddenly I was like the moment I came to Delhi, I suddenly tweeted on my feed, is there any meetup lined up in this week? Though he happens to be the one who commented on the feed, and that's why I came to know about this event. This is happening in the Gurgaon. So
So I'll
that's
tell you
all.
one
इसमें
thing.
I want to
There's
thank
a
you big time.
Yeah, there's a
अरे
lot
पूरा
of
तो ले गया,
events,
इसे तो ले गया,
like,
मैं ये आ गया
uh,
अगर यहाँ पे नहीं आ रहा
This
ना
is
तो
one
में
of
नहीं आ
the
रहा।
best meetup.
Yeah, I see. Yeah, exactly.
Yeah. So yeah, just
ये
fix
तो
that
audio
in
है।
your mind, okay?
बहुत कर दिया क्या
Okay,
इसको?
now we have another one, Krish, my friend. So I met him in ThoughtWorks, yeah? So in Gurgaon. Yeah, you can say.
प्रोजेक्टर पे जैसे
Yeah,
इधर
just
तो आ रहा
give
है।
it.
Thank you so much. What's your name?
रीसेट कर दिया कर जब ऐसा कोई दिक्कत है
Shailesh. Thank you so
अभी
much,
कर
Shailesh.
ओके ओके कर उसको
आ गया अब उसको अंदर बीच में लेके आओ आप स्लाइड
एक मिनट
Hello. Yeah, so I'm basically building a product right now in which like 30 to 40% of it is related to cloud AI. So I'm not from that field and I wanted to explore it and see what new products are going on. Like something like Raise, something like I actually would use in my product. So that was my main motive to come here, to actually explore something which I have not done before, to use cloud AI very much. I'm mostly related in other fields like deep tech research or now iOS development. I might use some new products that I've learned here. So yeah, that was the main motive.
Yeah, one more thing. Can you please brag about you? Yeah.
I don't like
Yeah, I'm insisting. Yeah, please.
Okay, so what she's talking about is that I wrote a book on the C programming language when I was 15. That's how my journey started, and I kind of got a research grant. Or from that, got into Arduino. Then currently spend like 2 to 3 years in quantum computing, researching. I have a paper which will be published in the next year or so. It's under review. So my long-term field is quantum computing, but currently I'm doing iOS development, building my own startup. It's basically an e-commerce platform using augmented reality and AI to help sell home interior stuff like furniture. So that's the basic background.
Can someone guess his college? It's very easy to guess. No, bit related to the startups and all.
Bits.
Yes,
Yeah,
bits
so
below.
he's from Bits Pilani, second year, so it's great person to connect with, so you can connect with him.
Thank you, everyone.
Thank you so much, Krish. Anyone who wants to tell why they are here? Any women I want to hear from them? Yeah.
You want? Okay, yeah, next. You can.
I have been exploring cloud native since long और अभी after AI has come तो I have been listening about AI plus cloud going a lot. So when I saw this cloud AI, I got to know this by Sudhanshu. I'm connected with him on LinkedIn only. He reposted that he is going to speak here. So I quickly registered here. So I am here to know more about AI and cloud, how it's gonna be a boom in the next coming years. So yeah, that was my motive.
Great being your all women friends, so yeah.
Yeah, women in tech.
Yeah, women in tech, guys. Okay, you want to? Or, okay, next time. Yeah, please.
Are you guys ready for the next talk or not?
Yes.
Or you are enjoying me here? Chalo. Let's go for the next talk, and it's from Shaurabh Prateek. He's from Google. So his talk title is Building and Deploying Your Graph-Based Databases on Cloud Using Neo4j. So how many of you are worked with databases? I mean, most of. Neo4j? 4J, sorry. You work?
We are planning to do it. That's the main reason I'm here to know about your project.
So, congratulations, Saurabh. That's great. Okay, so yeah, please round of applause for the Saurabh Prateek. Please come on stage.
Hey, hello everyone. So my talk is on graph databases. Anyone have, like, among you have used graph databases before? How many of you have used databases? Relational? No SQL? Not graph databases, right? So in this talk, we'll basically talk about why should we use graph databases, like on what are the basic use cases where graph databases can be more useful, the queries can be more optimized, and which are the situations where we can leverage the graph databases. So okay, before I dive into it, okay, my name is Saurabh Prateek. I'm a web solutions engineer at Google here in the Gurgaon office. And yeah, the agenda of the talk basically will start with how relational databases and graph databases are different from each other. Then we'll talk about Neo4j. So Neo4j is an organization who deal with these graph databases technologies. They have built AuraDB, which is provide graph as a service. You can deploy your graph databases on AuraDB and you can use it. It has integrations with Google Cloud, Microsoft Azure, and AWS. And we'll talk about the concepts of nodes and relationships when you deal with the graph databases. We'll also try to understand how you can model your design on Neo4j. We'll discuss Cypher. Cypher is a query language which queries graph databases, basically Neo4j for you, right? As same as SQL queries relational databases. Cypher is the thing you want to go for when you are querying Neo4j graph databases. At the end, we'll discuss one interesting use cases regarding modeling the graph databases, and at the end, we'll discuss the applications. Agenda clear? Cool. So first, let's discuss about relational versus graph databases. So can anyone tell me, do you think any scenario where you can leverage graph databases, and on these scenarios, the relational databases might not work?
Social media.
Social media, yeah, that's the first thing. So earlier what we used to do is that we simply store the data in form of tables. Like we used to think that, okay, these are 5 to 10 types of rows which can be mapped to one entity. Then what we will do is that we'll call that entity as a table, and we'll put all those data into that particular entity and we'll store them. And that was simple because earlier the softwares were simple. Then we came into the era of social networking where we have different kinds of use cases. Suppose if on social network I can say that how many friends I am connected with, or what is the how many mutual connections I have, or if I am a person and you are a person too, then how many networks or how many hops are there between you and me, right? There are a lot of different access patterns, which if you are following a relational database, it might be very difficult to answer all of them in a constant time space, and that is why we we are using Neo4j. Neo4j is also used for LLMs. So if you want to dive into and understand how a particular model is looking like, what are the nodes, what is the bias there, you can use Neo4j to model that. So yeah, that was one interesting use case. That is the social media platforms where we can leverage Neo4j databases, graph databases basically. So yeah, relational databases basically store the data in the tables in a normalized format, where Neo4j says that, okay, give me, I'm gonna store the data in a very similar way you basically whiteboard your data, right? So you whiteboard the data in the form of nodes, you connect them in the form of between them have edges, right? We will store the data in the same format, right? So how many of you have used graphs before? Okay, one. Graph data structures. So graph is basically a combination of nodes and edges. what we have is that we have entities called nodes, and those nodes are connected with edges. Now, Neo4j says that we store the data in the form of graph at the most abstract, at the most low level, so that you can perform your graph algorithms on top of it. So if you want to find the shortest distance, like if person A is connected to person B, what is the shortest distance between them? Meaning how many persons are there in between them? Like in LinkedIn, you have seen the number of mutual connections, first, second, third, right? You can go in depth into it, and you can do all of these things in an optimized manner, because you can perform graph algorithms on top of it, which runs in a logarithmic complexity, right? Which you can't do in the relational database. Think of it. If in a relational databases you are storing a lot of people here, and if I say you that, okay, tell me that person A and person B, how many people are there in the connection between person A and person B? Like, is person A and person B directly connected, or is if there are 2 to 3 mutual connections in between them? How will you do that? You have no ways if you have to basically join the table, find the person A, person B, and that is for one bridge. You have to, like, suppose if you don't get a direct relation, if person A is connected to person B to person C, and that is connected to person D, you have to form multiple joins on top of it. And you have to do all of that in real time, because you don't know which person the query will be coming from. There are millions of people on social media, so you don't know which person query can come from, right? You can't pre-compute it. So that is the essence of Neo4j. In Neo4j, you don't have to join it. In Neo4j, you can directly hop from one person to another, because there are relationships built between nodes. So Neo4j says that you can do all of these things in a real time, because I store my data in that format. That is the whole essence of Neo4j. So if you are, like, maybe you are trying to explore the use case of Neo4j, and we are trying to work with these kinds of models where the data looks very similar to the way you whiteboarded, right? So that is a very ideal situation where you might want to store your data model.
If you allow me, so in our company we are planning to do it for healthcare insurance, build an analytics platform where we can show the relation between insurers and the providers, then the providers, then the pharmacy, then the
yeah. So you understand that there are,
yes.
Exactly, there are multiple bridge. So yeah, you can use that. Maybe I would suggest to, like, do a POC on a limited amount of data, but different entities. Try to see how Cypher is performing.
Just a thought that came as of now. We have not explored it yet, but I am the one supposed to do the exploration. Can be taken on board.
Yeah, then you should do that. Okay. Awesome. यहाँ तक everything is clear, or like is there any doubt? Yeah.
Uber uses graph databases, right?
Sorry.
Uber services uses graph databases, right?
Uber services does not use Neo4j. They have their internal, I guess.
I'm just asking, like, graph databases.
Yeah, they use that. So Uber has to perform a lot of, like, computation, right? So Uber use that, Google Maps use that. Graph database is not new. They are using it, but Neo4j has made it popular. They have made it open source for us to use.
Asura is also there, right? Asura is also there, right?
Okay, it's a competitor. I have not heard about Asura. Like, is it a graph database?
Not a graph. I would say GraphQL engine. I think that.
GraphQL.
Engine, yeah, GraphQL.
GraphQL is a different thing, I believe.
But it does it in the same way. It does it in the same way, like that.
Okay.
To figure out where the nodes are. Basically, you write kind of a query in such a manner.
Exactly, and they get rid of all the
complexities.
Properties you don't
basically,
want.
on a relational database, you kind of
Exactly.
running GraphQL.
Oh, okay, awesome. So yeah, Uber and Google Maps use that, but they have their in-house graph databases, which they have made it popular or open source. Yeah. Any other questions apart from that?
Sir, have you ever worked with the Superbase technology?
No, I haven't.
I think it does the same thing which Superbase.
Superbase is also.
So what is Superbase? Like, what does it do?
Superbase, it's a open
So
source.
same work and functionality you've talked about. That's what like the new forcing.
Which you talked about this relational database in the graph format. So what happens, like, in general you talked about the complexity of the table making and all, and this Neo4j thing allows you to kind of get away from the complexity of, like, let's say one people are connected with the 5 all around, and you will be having the data from all of them and dynamically. So that complexity gets you in trouble in order to find it and maybe segregate the exact one data, which like from where it's coming from exactly, the source and origin of it. So in case of Superbase, it does the same thing. So what happens is that, like, basically, for example, me as a person holds, like, different attributes. For example, let's say about my personality, right? Strength and weaknesses, I can have different. So मेरा एक खुद का एक एंटिटी बनता है with the help of Superbase. It's quite easy. Like I'll ask you, Arjun, to please go and check out. It's an open source. तो एंटिटी बनने के बाद सिंपली आपको क्या होता है कि आपकी एंटिटी जब बन जाती है तो फिर आपने बताया कि मैपिंग की जो वो है वो थोड़ा ज़्यादा कॉम्प्लेक्स कर देता है. Even that process is also like at ease with the use of this whole Superbase technology. So that's what I wanted to ask you, is there any difference between these, the Neo4j and the Superbase which I talked about?
I can't comment actually, I haven't used
Okay,
Superbase,
you have not, sir. Sure.
maybe I will use it and then I can comment on it.
Yes, sir. I urge you to please check it out once because
Yeah,
I think it does the same thing which you talked about. Neo4j.
Okay, so it's a separate open source project.
All treated, yeah. Open source. Complete open source.
Superbase.
Superbase. Superbase.
Superbase.
Great.
Okay, so Neo4j. We'll talk about Neo4j basically. So Neo4j is a graph database and it is not an abstraction layer. So it's not the case that it is storing the data in a relational format and it is giving a graph abstraction layer on top of it, making a fool all of you. But it's not the case. It is storing the data in a graph format at a lowest level, and that is why the queries are optimized. So they store the data the way it looks like on the whiteboard or the way I will show you on the dashboards. So that is one case, and another thing is that Neo4j offers its graph database powered as a service using AuraDB. So when you go to Neo4j, you can go to the AuraDB open dashboard where you can create an instance. They'll give you a password. It's open to everyone. You can simply create an instance. They'll give you a password. You save it, and then when you create the instance, you enter the password, and after that you are into the graph environment. You can create nodes, relationship, and you can query them using Cypher. You can also import your data if you have a huge amount of data, like if you are planning to do some POC and if you have a data in a CSV format of your pharmacy and all the other entities, then you can simply offload that or import that into the dashboard, because it is not possible to write query to create all those nodes and relations, right? So I would suggest you to best format the data in the CSV format and offload all the data into the Neo4j. Once your graph is ready, you can perform your query using Cypher. You can see what is the response time of your queries, and if it suits your threshold, whatever millisecond threshold you have, you can do a POC on that. Right? Okay, so why should we use Neo4j? So the first thing is that Neo4j, the data is at a lowest abstraction level, it stores the data in the graph format. So whatever operations or whatever algorithms you are applying on it, they will be optimized. It is not performing any pre-computation. It is not storing the data in a relational format. It is not performing any pre-computation on top of it to show you the data in the graphical format. It's not the case. That's the first thing. Second thing is the flexibility. So what you can do is that in the SQL or relational database, you might have an entire idea about your tabular structure, right? You should know that, okay, these are the columns these are the primary keys. And if there is any change in the schema, it is hard to adjust on it, right? But in the Neo4j databases, it has a concept, it does not have a concept of tables, it has a concept of nodes and relations. So if a node change, if the property of a node change, if the relationship between two nodes change, you can easily modify your existing schema, your existing model, and it will adapt to it. Third thing, the support for the programming languages. It has the drivers for supporting these programming languages basically. Java, JavaScript, .NET, Python, and Windows. If you want to there is a dashboard where you can it's a UI where you can use it manually. But if you want at the end of the day you want it to be connected to your servers, and servers you'll be writing using a programming language, server language, right? So you can use Java and all these their driver libraries to connect with them. Yeah, in Python as well. If you're using Django servers, you can write on it. Yeah, you can write on it and connect with them. Any doubt till now? Should we move on? Okay, so now we are into the concept of Neo4j or a standard graph database. So the first building block of a graphical database is nodes. So what are nodes? Nodes are the basic entities. So if you see, I have two nodes here. One with the name of Dan and another with the name of Anne. So nodes are the entities in the graph. Nodes can be tagged with labels. So labels are basically set, right? Multiple nodes can be a part of a single label. So here you see these are the two nodes which has a label as a person, right? So we have two nodes which are person. Nodes can also have properties which are displayed in the form of key value format in the Neo4j databases. So if you want to have a lot of metadata for a particular node, you can store them in the form of properties. For an example here, for this node, the label is person, and the property is, so the first property is the name, which is Dan, and another you can have maybe age, you can have address, you can have mobile number and a lot of things. Similar for Anne as well. So node is clear, node, labels and properties. Is it clear? Second thing is relationships. So relationships is basically how one node is associated or connected to another node. So here Dan is connected to Anne. He basically, Dan loves Anne. So Dan is connected to Anne in this format, and in like graph databases, the relationship is always directional. So you can't have a bidirectional or a unidirectional edge. The relationship should be directional. That is why there is a relationship is directional. It goes from Dan to Anne, right? So that is a relationship. Relationship can be from, it will always be from one node to another node in a directional format. Okay. And relationships can also have properties, right? If you want to have more metadata or more information about a relationship, then you can also have that. So relationship also has the capability to have properties. You can store a lot of details for our relationships in Neo4j.
Isn't not having bidirectional disadvantage?
I think it is a disadvantage because if you want to show a bidirectional relationship, you have to make a two unidirectional relationship. Exactly, but I have seen in most of the use cases, they use a unidirectional relationship. So for example, your use case, the pharmacy one, I don't think you will see a use case where you'll be using a bidirectional relationship. Just think about it.
If I want to go from bottom to top.
Pharmacy sells something to a customer, it will always be directional, right? So that is why I think they have given a thought on it, and that's why they have not provided any support. If there was a use case, if there was a lot of use case, the community would have themselves like given a pressure that hey, give us the support of bidirectional relationships, right?
Is there any existing graph database happening in bidirectional relationship?
In Neo4j, no.
Other than Neo4j?
I'm not sure about that. This is the only graph database I am currently exploring actually. So maybe you can take a look at it, but Neo4j, they have specifically mentioned that they are not supporting bidirectional relationships. Cool. Modeling your data in Neo4j. As I mentioned, Neo4j stores the data in a graphical format. So this is one of the model where there are some movies, actors and directors. So you see Tom Hanks, Hugo Weaving, they have acted in a movie together in Cloud Atlas. And another Hugo Weaving has acted in The Matrix, and Lana has directed both the movies, The Cloud Atlas and The Matrix. So if you want to store this data in a relational database, what do you have to do? Any idea?
Have three separate tables with actors and then movies and then directors. And then do relations.
How will you do relations in relational databases?
Primary keys and all that.
How will you do the relations in the relational databases?
Foreign key. Primary key. I will use
The
GraphQL
primary
on
key,
top.
foreign key is okay. How will you connect them? Normalization. You will have to have a separate association table for it, right?
Kind
Where
of,
you will
yes.
associate the primary keys of two table as a foreign key and an association table.
Yeah.
Lot of work for it, right? But Neo4j says that you don't have to do anything. You just create nodes and relate them. That's it.
But I have a question. So you're saying I would have to basically create another table to figure it out basically, right? Who is directed and what's the relation? So like I said in GraphQL, right? Like any GraphQL database like you have in the market, you can create a basically or a same kind of SQL query that hey, I want to find out who directed and who acted. You can create a join multiple table, and that will happen on the fly for you. So basically there is optimization for you. You don't have to create a whole separate table. Keep it ready basically. It will be more like on the fly for you.
That makes sense actually, but my question is that if I have like multiple level of relationships,
Yeah,
so
again,
it's a single
like
level
it will
relationship,
go-
GraphQL does that for me.
So it will go for the same thing like again.
And how
for
will
example,
you do that?
For example, in case of a graph database like this, when it becomes like a very larger one, you would have to iterate through multiple nodes to basically get information. Again, it creates a problem of the same efficiency.
No,
How much?
it does not actually. So node can be indexed, right? So if you're looking for a node, there are labels and.
So yeah, again, in case of graph database, I can create a metalized view that won't be like it will be always in radian shape, but it will keep a database whenever I need it. So it will create like a screenshot or
So
something.
okay, so you're mentioning that GraphQL does optimization on top of relational database so that you can perform graph queries on the fly.
Yeah.
Okay, cool. It isn't. I'm not saying that it's.
No, I'm
not
just
bad.
saying
I have seen GraphQL is a
it is
technology.
a possibility that people always rely on relation database more than graph.
Exactly, yeah,
right?
that is true.
And people wanted to figure
And
out a way to work with
yeah,
it.
that is one reason GraphQL is so
GraphQL.
popular because they don't want to migrate. If I
Migrate.
am having millions of users already stored in relational database.
Why would I want to?
I will never do that. But for new folks,
Huh.
if
It
you
is
can do
good,
that.
it is good.
So GraphQL is a super amazing technology built by Facebook, Meta actually.
Yeah.
They released it.
So Meta also use GraphQL, but in behind they use relational.
Yeah, exactly that.
Yeah.
So GraphQL is just an abstraction on top of relational
Abstraction on
database.
top of
So
it.
it will
Yeah.
help you
Yeah.
optimize your queries
Yeah.
if you like,
Right.
want to query in a graph format. So any GraphQL questions, please correct me.
No, no, no.
And for new So yeah, so is it like okay? That makes sense. So we have this nodes, and if you want to create a relational model, you have to create some tables, you have to create some associations, and a lot of work will go on, right? And now Neo4j says that if you want to model the same data in Neo4j, your data will look something like it. Where you have nodes, Tom Hanks, Hugo Weavings, Cloud Atlas, the matrix, and all you have the nodes, and these are related in this form. So the relationships are here. Tom Hanks acted in Cloud Atlas. Lana directed Cloud Atlas, right? So these are the relationships in which you are representing your entire model in Neo4j. Does that make sense? Let's wait some time. You can look into this design. That looks good. Okay. Any questions on this design?
बहुत सारे we have like बहुत सारे layers.
कर सकते हैं. A node can be mapped to different.
Complex.
नहीं complex नहीं होगा. Like this is the see if a node have relations to 100 other nodes, you have no way but you have to build that relation, right? So that is the like most simplest thing you can do. The fact is that your most simplest design is itself complex. So you have to deal with it. So designs are complex, and you are trying to like. Query time will increase, but I feel that these nodes are indexed, which help them if you want to identify a particular node. You don't have to search through all the million nodes present in Neo4j. The indexing is there, where you can hop onto the particular node directly, which will help you to query the issue.
Just to add to a question, what if there are multiple relations to a single node and that node itself absorbs? मतलब इसका essence खत्म हो गया, मतलब it is not existing. Multiple relations थे, but now it is not existing. So
I haven't tried it, but I think if you delete a particular node, then all the relationships which are attached to those nodes will not make sense and will be deleted. So I think if you delete those nodes in Cypher will give you the warning that hey, you're trying to delete these nodes, but they are already related to multiple nodes. So the correct way to delete a node is to first get rid of all the relationship mapping to it. It's the classic foreign key constraint. Remember, if you want to delete a particular child, you can't, like if you want to delete a particular primary key or a particular entity, you have to get rid of all the other relational entities with it, right? Foreign key constraint. Otherwise, SQL will give you warning that you are deleting this primary key and there are multiple child tables associated with it. And they will not make sense exactly. Right? That is the whole concept here. So if you are deleting a node, all the child relationship will not make sense. So the right way is to get rid of the relationships attached to a node, and then you can maybe safely delete it.
then rewiring the relationship would it be more complex?
Rewiring means you're basically connecting a node to a different node, right? So you can create another relationship to another node because that node is already written off and the relationships but that are directed to that node is also deleted, right? So you can build new relationships. And finally, so the final model will look like this, where earlier we have the nodes where we have three different labels now. So the first label is the person, the second label is the movie. Oh sorry, two labels. First label is the person and second label is the movie, right? And then person have their properties as actor and some of them are director. And then you can see more properties here where name is Tom Hanks, his birth year, right? The movie title and when was or the year on which the movies were released, right? So these are the labels which help you to answer very interesting questions which you will see ahead. You can see also the